Good afternoon, sir.
Okay, so beta last lecture we were discussing about the special point on the great circle track. That is the vertex of the great circle. So we had discussed a few properties of the vertex. So today we are going to revise the concept of vertex. That's number one. Then after vertex, we will revise a spherical trigonometry formula, that is the Napier's rules. Do you remember Napier rules? Second mates and Prisi, we had done them.
Yes, sir.
Yes, थोड़ा बहुत याद है.
Anybody remembers the formula? Sine of middle part equal to?
Cos of side 1 into cos of side 2, tan adjacent side 1 to tan adjacent side 2.
Okay, all
Yes,
right.
sir. Sine of middle part, cos of opposite part 1 multiplied by cos of opposite part 2.
Very good, Ankush. Very good. So that is one formula. The second one is tangent adjacent. So anyway, we will revise both those formulas. So we will do the vertex first, revise it once again, then go into the Napier's rules. We will see how those Napier's rules are applied. We make a cartwheel, we make a circular diagram, and we fill up the parts in that diagram. And once we are familiar about the application of Napier rules, then we can proceed ahead and solve questions related to finding the position of the vertex. Now, why we are so interested in vertexes? Vertex helps us to find out the intermediate positions on the great circle track. Why are intermediate positions required? Intermediate positions are required to make a actual passage plan on the ship. If we do not have a EGDIS, if we do not have a mnemonic chart, then in that case we have to use this manual concept which we will be learning now to find out our intermediate position and prepare the great circle passage plan. Second reason why we are finding these intermediate positions is that in MMD questions you will get questions now where they will tell you to find a particular position on the great circle track. Now we could find position in some of the cases by using cosine formula also. Assignment 1, there were some questions where we could find the positions, especially where the distance of the position is mentioned with respect to A and B. If distance is given to us, we can use the cosine formula and find that position. But if distance is not given to us, then cosine formula will not be of help. So this is the importance of vertex. It helps us to find the intermediate positions and helps us to make the passage plan. So this is our next target now. First, find out the position of the vertex, and next find out the intermediate positions. So I'm going to go with the video and I'm going to repeat the few slides which we had done in the last session also related to the vertex so that the concept gets strengthened. Now, do you remember, beta, I told you the direction of the great circle track when it reaches on the vertex is what? Do you remember?
East-west, sir. East-west.
East or west?
East-west, sir,
090 or
90 or
270.
270.
Very good, beta. So it's good you remember that. So the direction of the great circle track is always east-west when we reach at the vertex. So this is a very important property of the vertex, which is utilized in calculating the intermediate positions. So let's start off with our presentation on video. Have you seen this channel, beta? Did you have a chance of going on YouTube and checking out this channel?
Yes, sir.
Yes, sir. Also watch some of videos.
Okay, so how did you find the videos?
Yes, sir. Good.
Good, sir.
Any feedback?
Yes, sir. Very good video, sir.
गुड सर सर ये ड्राई डॉकिंग की भी बना दीजिए सर स्टेबिलिटी में
बेटा अभी नेवल आर्किटेक्चर वीडियोस जो हैं वो चल रहे हैं. सो अभी वी आर राइट नाउ कंसंट्रेटिंग ऑन द बेसिक्स. द लास्ट वन विच वाज पब्लिश्ड वाज ऑन center of buoyancy and center of gravity. So once these basics are done, then we will move on to these concepts also.
सर आई थिंक बस ऐसे ही सजेशन के लिए बोल रहा था कि अगर उसमें कुछ वीडियोस लाइक यूट्यूब ऐसे कुछ वीडियोस जैसे यूट्यूब पे दिखाते हैं वो कुछ एडिशन या ऐड हो जाए तो और अच्छा हो जाएगा. बट सर दे आर नाइस, दे आर वेरी गुड वीडियोस, एवरीथिंग इज अंडरस्टैंडेबल.
Okay, all right. What you were saying, beta, initially?
जैसे ही सर जैसे वीडियोस उसमें ऐड हो जाए ना, जैसे शोइंग शेप लाइक जैसे यूट्यूब.
I got it.
यस सर. कुछ अगर उसमें ऐड हो पाता
Like animation.
लाइक
थोड़ा इंटरेक्टिव हो जाएगी
शोइंग
सर तो
टाइप
फिर
वीडियोस.
प्रेजेंटेशन
इंटरेक्टिव हो जाएगी तो बोरिंग नहीं लगेगी किसी को भी मतलब मन बना रहेगा ना.
Okay, all right. Okay.
So otherwise they are very good videos, sir. Problem.
Okay.
Very nice.
Okay. ठीक है बेटा. The feedback is taken. So we'll try to modify it that way. So anyway, let's for the time being go into the vertex and the intermediate positions.
As to what does vertex mean. Let us take any great circle on the surface of the earth. We see in the diagram the sphere of the earth showing up. We have the poles of the earth coming up on the diagram, followed by equator. And now we take any great circle except the equator. So equator has been left out of our discussion currently. So we take any other great circle. You can see an orange great circle showing up in the diagram. And we consider randomly points on it marked from A to H. So you can see these points also randomly showing up on the great circle drawn on the surface of the earth. Now, if a vessel moves along this great circle, starting from A, along the direction of arrows which are coming up on the screen, so she goes right round this great circle and returns back to point A. What do we see as the vessel sails along this great circle? We see that at each point, the vessel has a different course. Why? Because the great circle track cuts the meridian at each point at a different angle. Also, the coordinate of each point along the great circle, that is their latitude and longitude, are different. And what do we see as far as coordinates are concerned? That of all the points along the great circle, point D is the point where the vessel shall reach the highest northerly latitude. And likewise, point H would be the point where the vessel shall reach the highest southerly latitude. These 2 points, D and H, where the great circle has the highest latitude, or the points having the highest latitude along the great circle, are the points referred to as the vertices of the great circle.
Okay, beta, if you have not written this definition, you can write it down in your notebooks. The vertices are the points of highest latitude for a great circle track. So if you have not written it, just note it down and let me know once done. Done, beta? Note it down.
Yes, sir.
Okay.
Yes, sir.
Okay, beta.
So D and H are the vertices of the great circle. So based on the explanation of the vertex of a GC is a point at which the GC reaches the highest or maximum latitude. In other words, these are the points on the great circle which are closest to the poles. Now, based on this discussion, let's evaluate as to where are the vertices of the meridian. We know all meridians run north-south. Their highest latitude are the geographical poles. Therefore, vertices of every meridian happen to be the North Pole and the South Pole. Where are the vertices of the equator? Now, if you recall, when we started our discussion on vertex, we had left out equator. Why? Because equator is a very special great circle which runs in the east-west direction, and latitude of every point along the equator is 0 degrees. So therefore, the concept of vertex shall not apply to equator. Why? Because the latitudes are measured with respect to equator itself. Now, having understood what vertex means, let us understand some of the features of the vertex which will help us in solving certain questions. Now, every great circle, of course, excepting equator, has two vertices that are diametrically opposite to each other and one located in each of the hemispheres. With respect to this great circle in question here, we can see it has two vertices, vertex D and vertex H, diametrically opposite to each other, vertex D in the northern hemisphere and vertex H in the southern hemisphere. At the vertex, the great circle track is exactly east-west, and the other way of saying the same thing is that the great circle course of the ship at the vertices is east or west. That means it does not have any northerly or southerly component.
Beta, had you noted this property? At the vertex, the GC track is exactly east-west. That is, the vessel's great circle course at vertex is 090 or 270. If not, please write this also down. Only this particular point.
कल नोट डाउन किया था सर ये.
Okay, all right, beta. ठीक है. Let's continue further.
Now, to understand this, let's have a look at the highlighter moving along this great circle track, and we can see as it is moving along the great circle track, the northerly latitude is increasing. And we all know that this increase in northerly latitude is because of a northerly component in the course. And of course, this northerly component is continuously changing. What do we see as the vessel goes past point D, that is the vertex? The vessel's northerly latitude starts decreasing. Now, we also know that if the northerly latitude has started decreasing, the course must be now having a southerly component. Therefore, the vessel, as it was moving along here, the track here, had a northerly component of the course, then it has the southerly component. So somewhere this change has taken place, and the place or the point where the change takes place is point D, where the northerly component was continuously decreasing, becoming 0 at the vertex before the southerly component sets in. So at the vertex, there is no northerly component of the course, there is no southerly component of the course. Therefore, the vessel's course will be either east or west.
Okay, Beta, just to test the understanding, let us say our ship is going from C to D. So if the ship is going from C to D, one thing which we know, it is moving in the easterly direction. So can you tell me what will be the quadrant in which the vessel's course or heading lie?
First quadrant is a northeasterly.
This is northeast.
Very good, Beta. So when the ship is moving from C to D, our course or heading will be in the northeast quadrant. And when you reach at the vertex, what will be the course?
It will be east 09.
Very good, Beta. Very good.
09.
When you reach at the vertex, the course would be exactly 090.
090.
And when you cross the vertex and the ship is between D and E, delta to eco. Now, can you tell me what will be the quadrant in which the ship is going?
Southwest.
Southwesterly. Southwest.
Southwest or southeast?
Southeast, sir. That is southeast.
Southeast.
Right, it will be southeast. So you see, beta, let us say when the ship is at point C, the course I assume is 050. As you move ahead, after some time, the course would become 060, 070, 080, and then when you reach at D, it will be exactly 090. As you proceed ahead, it will become 095, 100, 120, 130, 140, and so on. This is how the course of the ship keeps on changing when you are moving on the Great Circle track. So were you able to understand this, beta?
Yes, sir.
Okay, let's proceed ahead now.
As the vessel is always aligned along the Great Circle, therefore, it also means that the Great Circle track at the vertex or the vertices is running in the east-west direction. The vertices will be located with a D long of 090 degrees from the positions where the Great Circle cuts the equator. Now, this Great Circle is cutting the equator at point P and point F. Vertices are D and H. That means D long between B and D is 90, D and F is 90, F and H is 90, H and B is 90. It's very simple to understand that. If a vessel starts from B, goes along the Great Circle track and comes back to point B, the D long is 360 degrees. Now, these points, that is point B, D, F, H, B, they divide the Great Circle into 4 quadrants. And now, since all these 4 parts are equal, being the quadrants of the Great Circle, so if along the entire Great Circle, the D long was 360 degrees, then the D long for each quadrant shall be 1/4 of it, that is 90 degrees. The latitude of the vertices will be equal to the inclination between the plane of equator and the plane of the Great Circle, or the angle at which a Great Circle cuts the equator represents the latitude of the vertex. So first, let us identify the angle between the planes of the equator and the Great Circle. This is the angle in our case. which is the angle of inclination between the plane of this great circle and the plane of equator. Now, if we join this point D with the center of the earth with a straight line, I'm sure we can all visualize that this particular line shall be in the plane of the great circle. So if this line is going to be in the plane of this great circle, then this line shall make the same angle as this one with the plane of equator. And we all know that the angle subtended by a point on the surface of the earth with the plane of equator at the center of the earth represents its latitude. Therefore, this angle of inclination becomes the latitude of the vertex.
So were you able to understand this point, beta? Okay. What it says, beta, this property of the vertex, it says the angle of inclination or the angle of cut between the plane of the equator. The blue color plane which you see in the diagram is the plane of the equator. So the angle between this and the plane of the great circle, this angle is represented or highlighted by the orange color in the diagram. Now this angle will be equal to the latitude of the vertex. Is it clear now, beta?
Yes, sir. This is
Because it is a great circular plane cutting the plane of equator.
Yes, that's right. The angle between both of them will be equal to the latitude of the vertex. Now, beta, tell me one thing. Let me give you a small question to test your understanding of this concept. Let us say our ship is moving on a great circle track and we are at point B. Okay, we are crossing the equator and proceeding towards C. So our ship is right now at point B and it is proceeding towards C point, Charlie point. Now, let us say we know that this great circle track on which we are moving, its vertex is at 40-degree latitude. So the latitude of the vertex or latitude of point D is 40 degrees. Now, can you tell me, beta, what will be the course of the ship at Bravo point?
050.
Everybody agrees? 050, beta? Any other answer? Okay, good.
Still, latitude कितना बोला सर आपने?
040.
40 degree है बेटा latitude. Latitude is 40 degrees of the vertex of point D. So second option which is coming up is 040. Any other option, beta?
Sir, 050 होगा sir.
Very good. So it will be 050, beta. You see, if the latitude of point D is 40 degrees, that means this highlighted angle, the orange highlighted angle, will also be 40 degrees. That means with respect to the equator, our great circle track is at a 40-degree angle. Now equator direction represents east-west direction, so 090 direction. If you are 40-degree north of it, your course has to be 050. Our course is measured with reference to north and south, whereas the equator is in the east-west direction. So our course here would be 050. That's the correct answer, beta. So is it clear to everyone, beta?
yes, sir.
Yes, sir.
Okay, all right. Let's proceed ahead now.
great circle track intersects the meridian of the vertex at 90 degrees angle. This issue has already been addressed when we inferred that the course of the vessel at the vertices would be east or west, or the great circle track shall be east or west at the vertices. And we know these directions are measured from true north, and north-south is represented by the meridian. Therefore, the angle between the meridian and the great circle at the vertices shall be 90 degrees.
Now, this is also very important, beta. The great circle track will intersect the meridian of the vertex at 90-degree angle. Basically, what we are saying here is that this great circle track which you see, let us consider this point delta. We know at point delta, the great circle track is running in the east-west direction, 090 and 270 direction. So our great circle track is in east-west direction. And what is the direction in which the meridians run, beta?
North-south direction.
So we know all the meridians, they run in the north-south direction. In this diagram, this particular meridian which you see, NP2 delta, it is basically the meridian of the vertex. So meridian runs north-south. Our great circle track at the vertex runs east-west. So there has to be a 90-degree angle between them. So this tells us that the great circle track intersects or cuts the meridian of the vertex at 90-degree angle. So at the vertex, this angle would be 90 degrees, not at any other point, because at other points, the direction of the great circle track is going to change. It will not remain east-west. It is only at this particular point, that is the vertex, which is the delta point, that the great circle track will be at right angles to the meridian. So this is clear to everyone, beta?
Yes, sir.
Okay, all right. Let's proceed ahead.
A vessel's track may or may not pass through the vertex of the great circle. Of course, the entire great circle has only two vertices. We may be traveling only over a part of the great circle track. So it may include the vertex or it may not include the vertex. For example, if I travel along this great circle from B to C, then over this arc, I do not include any of the vertices. But if the great circle, if I have to travel from C to E, then I shall be passing through vertex D. So my track may include a vertex or may not include a vertex.
So beta, is this point also clear? That when you are moving on a certain portion of the great circle track, it is possible
Yes,
that
sir.
the vertex may lie in between your initial and final positions, or there is a possibility it may lie outside your initial and final positions. So is that clear, beta?
Yes, sir.
All right.
Yes, sir.
Now this is also very important when we calculate the position of the vertex. This is the first thing which we need to check. When we are given a question, find out the position of the vertex. The first thing which we need to check is whether the vertex lies between our initial and final positions or the vertex lies outside the initial and final position. ये पहली चीज है जो हमें चेक करनी होती है. इसका मेथड मैं आपको बताऊंगा कैसे इस चीज को चेक करते हैं. We can easily find it out. We do not need to make this full earth diagram. We can easily find it out using another method. So I will explain you what that method is. If you go from B to C, initial position is Bravo, final position is Charlie. Vertex will be outside your track. But if you go from C to E, Charlie to Echo, in that case, vertex will be inside or lying on your track. So this is what we will be checking as the first thing when we find the position of the vertex.
In our calculation, we shall be dealing with the vertex that is closer to our great circle track. So if it lies within the track, obviously that's the closest one. If it does not lie within the track, then our interest would be in the vertex that is closer to our track.
So this next point, it says because there are two vertices of every great circle track, which vertex should we find out? Let us say the question says find the position of the vertex for this particular great circle track. This is the initial position, this is the final position. So we know for every great circle there are two vertices. Which one should we find out? So in that case, we always find out or consider the vertex which is closer to our track. So if it lies between our track, let us say if you are going from C to E, then there is no confusion at all. The delta vertex will be the closer vertex. But if you are going from Bravo to Charlie, B to C, so then the delta vertex or the hotel vertex both are outside our track. So out of these two, which one we will be using? We will be using the one which is closer to us. So we will be using the delta vertex in this case. So this is also clear, beta. Any doubt up to here?
No, sir.
Very good.
To figure out whether vertex.
Okay, so now we move on to the calculation of the vertex principle. We have seen the properties of the vertex. Now, as I told you, beta, the first most important thing which we need to know is whether the vertex lies in between our initial and final position or it lies outside our initial and final positions. So how do we check that out? अब बेटा आगे जो टॉपिक्स हमारे आ रहे हैं, we have done basic great circle sailing question. Now we are moving on to vertex and intermediate position. Later on we will be moving on to composite sailing. All these topics, they are interconnected with each other. It basically means कि जो great circle का concept है, जो PAB triangle हमने बनाई है, angle A, angle B calculate किया है, GC distance calculate किया है. Now this knowledge will be required, this concept will be required till the time we go to the last concept of composite sailing. It is something like building a house. With the great circle simple questions, we have made the foundation of the house. Now with the vertex and intermediate position, we are making the ground floor. And then with the composite sailing, we will be making the first floor. So foundation has to be there, then only the ground floor and first floor can be made. So we will be using the same concept which we learned in great circle sailing to find the vertex, the intermediate position, and later on in the composite sailing also. So the question now in front of us is, we need to know the position of the vertex. Bolo beta.
Sir, then please ये पीछे वाली slide करना sir.
Okay.
पीछे वाला.
ये लो बेटा.
सर इसमें ये रिपीट कर दो सर, क्योंकि एंगल वाला जो पोर्शन है ऑरेंज वाला, क्योंकि इसमें आपने बोला बी का 40 डिग्री लैटिट्यूड है ना?
नहीं बेटा, बी का लैटिट्यूड नहीं, मैंने
दिया था
जो वर्टेक्स का लैटिट्यूड बताया था बेटा, बी तो इक्वेटर पे है.
Yeah, that's why I was confused. I was thinking it's at the equator.
No,
so the vertex was at.
Yes, the latitude was of the vertex. So delta point.
Yes, sir. ये एंगल वाला पार्ट, एंगल पोर्शन ये वाला रिपीट कर देना सर एक बार.
ओके बेटा, मैंने आपको जो एग्जांपल दी थी, that was the latitude of the vertex is 40 degrees. So it is given to us in the question. If the latitude is 40 degrees, that tells us that this particular orange color angle will also be 40 degrees. That is what the property of the vertex says, right, beta?
Yes, sir.
Okay. Now, if this angle is 40 degrees, what is the track on which the ship is moving if it is going from B to C? It means the fore and aft line of the ship is making a 40-degree angle with the equator. Right, beta?
90 minus angle.
Right. Equator is pointing in 090 direction. So equator is 090. You are 40 degrees north of it. So that means your course will be 090 minus 40. That is 050. That will be the heading of the ship at point B. Is it clear now, beta? Are you still there, beta, or gone? Looks like he's gone. Okay, so let's proceed ahead then.
Yes, sir.
So what we are doing now is we are trying to find the position of the vertex, and the first thing which we need to know is whether vertex is inside our initial and final positions or outside. So for this, we will have to first make the PAB triangle as we made in GC sailing, exactly like that. And we will have to calculate the great circle distance as well as angle A and angle B. इतना काम बेटा हमने ग्रेट सर्कल सेलिंग के क्वेश्चन में किया था. अगर हमें वर्टेक्स को ढूंढना है तो ये काम पहले करना पड़ेगा. Whether the great circle distance is asked in the question or not does not matter. If you want to find the position of the vertex, you will have to make the PAB triangle, find the GC distance, and then find angle A and angle B. So up to here, everybody is clear?
यस सर. सर जो
Yes,
लिमिटिंग
sir.
लैटिट्यूड के क्वेश्चन आते हैं वही भी सेम होते हैं सर, ये वर्टेक्स वाले ही हैं.
Ask again, beta.
सर मैं कह रहा था कि जो लिमिटिंग लैटिट्यूड के क्वेश्चन आते हैं,
Right.
वो भी सर वर्टेक्स वाले ही क्वेश्चन है सारे.
नहीं बेटा, जो लिमिटिंग लैटिट्यूड का कॉन्सेप्ट है वो कंपोजिट सेलिंग में आएगा. अभी हम इसके बात करेंगे व्हेन वी फिनिश ऑफ द ग्रेट सर्कल सेलिंग, वर्टेक्स एंड इंटरमीडिएट पोजीशन जब हम कंप्लीट कर लेंगे, then we move on to composite sailing where I will explain you this concept of limiting latitude.
ओके.
Okay, उसमें भी vertex use होगा, but I will explain it to you in detail when we reach up to there. So for now we do not have any limiting latitude anywhere. Okay, और कोई doubt बेटा अभी तक? Okay, now everybody is familiar with calculating great circle distance, angle A and angle B. इसमें किसी को कोई doubt तो नहीं है बेटा? Question solve हो रहे हैं? Okay, I take silence as tacit acceptance. So let's proceed ahead now and see that after solving the PAB triangle, when we find the GC distance, we find angle A, we find angle B, how to determine whether vertex is inside or vertex is outside our initial final position or the PAB triangle. So we are going to see that now.
To figure out whether the vertex of the great circle lies within the GC track of the vessel or it lies outside the GC track, we use angles A and B of the PAB triangle. We calculate the angles A and B And if angle A and B are both acute, that is both are less than 90 degrees, then the vertex lies inside the track, that means between A and B somewhere. Let's look at it through a diagram. We have the pole, we have position A, position B. We draw the meridians of both the positions. We join them with the arc of a great circle, so we have a PAB triangle. We solve it. We have already learned in volume 1 of this series on great circle how to solve for angle A and B. And if angle A and B are found to be both acute, the vertex shall lie between, somewhere between A and B. So we can take any point along this where we feel appropriate, represent that by V as the vertex. We draw the meridian of this vertex from P, and we have already seen in the features of the great circle that.
Okay, so beta, up to here is clear to everyone. Any doubt, ask me, beta.
Clear, sir.
Okay, so important thing जो हमें check करनी है, when we solve the PAB triangle, first of all we will be finding the great circle distance. As usual, जैसा हमने पहले किया था, बिल्कुल वैसे ही हम great circle distance find out करेंगे. After great circle distance, the next thing which we are going to find out is angle A and angle B. ये दोनों angles को हमने find out करना है. Now, once you find these two angles, look at them carefully. Whether these angles are acute, acute means less than 90 degrees, or is any one of them obtuse? Obtuse means greater than 90 degrees. So let us say condition number 1, आपने ये दोनों angle check किए. Angle A was 30 degrees, angle B was 60 degrees. आपने देखा कि दोनों के दोनों angle acute हैं, means 90 degree से कम है. अगर दोनों angle acute angles हैं, less than 90 degrees, the vertex has to lie between A and B. So the vertex will lie inside our PAB triangle. That is the first thing. So is it clear now, beta, in your mind? No doubt?
Yes, sir.
Very good. Now, beta, what is the direction of the great circle track on the vertex?
East or west?
Very good. We know the direction of great circle track at the vertex is east-west. And can you tell me in this diagram, beta, what is this PV, Papa Victor line?
Meridian.
Very good. It is the meridian of the vertex. You see, what was PA, beta?
Colat of
It is
A.
a colat.
Yeah, its
Colat of A.
magnitude was colat of A, and this was a part of the meridian of A. Similarly, the PB magnitude
arc
was
of the
equal.
meridian.
Yes, it is the arc of meridian of point Bravo. So similarly, Papa Victor is the arc of the meridian of the vertex. So we now have Papa Victor as the meridian of the vertex. The great circle track is moving in the east-west direction. So can you tell me what will be this angle V in both the triangles? What will be this angle, Victor?
90 होगा ना सर ये वाला तो फिर.
Very good, beta. Very good, very good. So if you have understood this, then our path becomes clear. This angle here at Victor will be 90 degrees.
सर ये जो PB होगा एक तरीके से कोलेट ऑफ अपना वो हो जाएगा ना वर्टेक्स.
Very good, beta. Very good. You are exactly thinking in the right direction. Papa
Okay, sir.
Victor magnitude will be the colat of the vertex. Exactly as PA was the colat of A, Papa Bravo was the colat of B. Similarly, Papa Victor will be the colat of the vertex. So if you can somehow calculate this PV side, you will be able to find the latitude of the vertex. Very good, beta.
Sir,
सर ये 90
this
डिग्री कैसे
angle
होगा
V
एंगल?
is
Okay.
sir angle V is getting 90 degree because of the it is running east west because of its course, right, sir?
राइट बेटा, एंगल V 90 डिग्री कैसे हुआ? देखो बेटा, जो पापा वेक्टर है ये है मेरिडियन. हमें पता है ऑल द मेरिडियंस रन नॉर्थ साउथ. और जो ग्रेट सर्कल है, ग्रेट सर्कल ट्रैक वर्टेक्स पे ईस्ट वेस्ट डायरेक्शन में रन करता है. सो डायरेक्शन ऑफ द जीसी ट्रैक इज ईस्ट वेस्ट. डायरेक्शन ऑफ पापा वेक्टर इज नॉर्थ साउथ. तो इन दोनों के बीच में क्या एंगल बनेगा बेटा? Is it clear now, beta?
Yes, sir.
Okay. So shall we move ahead now?
Yes, sir.
Yes, sir.
This meridian shall cut the great circle at 90 degrees at the vertex. So this angle is 90. However, on solving for angles A and B of the PAB triangle, if we find that any one angle happens to be acute and the other one obtuse.
Okay. अब बेटा हम आ रहे हैं सेकेंड कंडीशन पे. हमने एंगल A और एंगल B को फाइंड आउट किया बाय यूजिंग द कोसाइन फॉर्मूला. वन एंगल इज एक्यूट. एक एंगल जो है ये एक्यूट आ गया, मींस लेस देन 90 डिग्रीज. और जो दूसरा एंगल है वो ऑब्ट्यूस मिला है हमें. Let us say 110 degrees. So one angle is acute, other angle is obtuse. अब ऐसे केस में vertex कहाँ जाएगा? The vertex now lies outside the GC track. That is outside the PAB triangle. So अगर दोनों में से कोई भी एंगल obtuse हो जाए, ग्रेटर देन 90 डिग्री हो जाए, तो इसका यही मतलब है कि वर्टेक्स ट्रायंगल के बाहर बनेगा, अंदर नहीं बनेगा. दैट मीन्स आवर ग्रेट सर्कल ट्रैक विल नॉट हैव द वर्टेक्स इनसाइड. सो दैट इज द फर्स्ट थिंग. दिस इज क्लियर इन द माइंड बेटा? एनी डाउट्स?
No, sir.
अब बेटा दूसरी चीज आती है. हमें ये तो पता चल गया कि वर्टेक्स जो है ट्रायंगल के बाहर बनेगा. अब जो सेकंड डाउट माइंड में आएगा वो ये कि ट्रायंगल के बाहर हम इसे किस तरफ बनाएं. ट्रायंगल के बाहर तो हम ए की साइड में भी जा सकते हैं, ट्रायंगल के बाहर हम बी की साइड में भी जा सकते हैं. तो वर्टेक्स को किस तरफ बाहर लेके जाना है? सो उसके लिए ऑलवेज रिमेंबर, vertex will be always on the side of the obtuse angle. जिस तरफ obtuse angle बनेगा, greater than 90 angle बनेगा, हमारा vertex भी उसी डायरेक्शन में ट्रायंगल के बाहर बनेगा. So I will show you this thing now with the diagram. We will make the diagram here. Let's see.
Then the vertex shall lie outside the track and it shall lie on the side of the obtuse angle. Let's look at this through a diagram. Here is the pole, here is angle position A, position B, their meridians joined by a great circle track. PAB triangle solved for angle A and B. Angle A found to be acute, but angle B found to be obtuse.
So you can see in the diagram now, beta, one angle is acute and the other angle is obtuse. So will the vertex be inside or outside?
Outside.
B के
Outside, sir.
Very good. And on which
B
side
की
will
तरफ
be
बनेगा
out?
outside.
On the
B की
On
तरफ
the
बनेगा.
angle
B.
side.
On the
Very
side
good,
of B.
beta. Very good. You have understood. Great.
Now in this case, the vertex shall not lie on the track between AB. It shall be outside the track and the closer one shall be on this side of the great circle, that means towards the obtuse angle. So we mark a point somewhere here as vertex. So here is vertex, we draw its meridian through the pole. Needless to say, it will make an angle of 90 degrees with the great circle.
ओके अब बेटा चाहे वर्टेक्स अंदर बने या वर्टेक्स बाहर बने, जो एंगल V बनना है, angle V, that will always be 90 degrees, because whether the vertex is inside or outside, great circle track will always run in east-west direction at that point, and Papa Victor line which we are seeing, this Papa Victor line is the meridian of the vertex which will run north-south. So irrespective of whether it is inside or outside the triangle, the angle here at the vertex will always be 90 degrees. So is it clear up to here, beta? Any doubts in the mind?
सर एक डाउट है कि जैसे जब इनसाइड होगा तो पता लग जाएगा कौन सा हेमिस्फीयर में है एज पर द लैटिट्यूड ऑफ ए एंड बी, और अगर आउटसाइड होगा तो भी सर बी के पास वाले लैटिट्यूड में रहे.
बिल्कुल बेटा, जो भी आपका ऑब्ट्यूस एंगल बन रहा है उस पोजीशन को देखो, उस पोजीशन का जो भी लैटिट्यूड है आपका वर्टेक्स का भी वही हेमिस्फीयर है.
ओके
ओके ओके, और बताओ बेटा, और कोई डाउट आ रहा है?
Sir, कितना it will be outside. Suppose if the point B latitude is about closer to the equator, then
You mean to say the point B is close to the equator?
suppose
Okay.
Point A latitude is at 30 degrees south and point B latitude is 2 degrees south, about 5 degrees south. So if it is going outside on the obtuse angle, so it can be possible, it can be in go northern hemisphere.
नहीं बेटा, ऐसा कभी नहीं होगा. जो ऑब्ट्यूस एंगल बनेगा इट विल ऑलवेज बी द हायर लैटिट्यूड, ये कभी भी लोअर लैटिट्यूड में नहीं बनेगा. ये आपको ध्यान रखने की जरूरत नहीं है, ऑटोमेटिकली ऐसा ही होगा.
Okay, sir.
ओके
Sir, this is
बोलो.
Ankush. I completely missed out, sir. There was a internet connection lost. Completely missed out everything.
नो
on that
नो
question I
प्रॉब्लम
asked.
बेटा, डोंट वरी एट ऑल. ये वीडियो यूट्यूब पे अवेलेबल है और
Yes,
अभी
sir.
आप क्लास के बाद इसको डाउनलोड कर लेना. यू शुड बी एबल टू डाउनलोड इट, सो नॉट एन इशू. यू कैन हियर टू द लेक्चर अगेन, एंड जितना भी आपने मिस किया है उसमें अगर कोई भी डाउट आता है, आस्क मी इन द नेक्स्ट क्लास.
जी. Okay, sir.
ओके और बताओ बेटा, और कोई डाउट है अभी तक?
So, sir, naming of the vertex which is lying outside of the triangle will be always same as obtuse angle latitude, right, sir?
दैट्स राइट बेटा. जो भी आपका ऑब्ट्यूस एंगल वाली पोजीशन का लैटिट्यूड है, आपके वर्टेक्स का लैटिट्यूड भी उसके सेम नेम का ही होगा. So shall we move
Okay, sir.
ahead? Shall we move ahead now, beta?
Yes, sir.
Okay.
Now, having identified whether the vertex lies inside the track or outside the track, what do we use it for? What is our interest in the vertex that we have discussed it for so long? Now, the importance of vertex lies is in the fact that the vertex, the meridian of the vertex, cuts the great circle at 90 degrees. So this angle at the vertex between the GC track and the meridian of the vertex is 90 degrees, is a very, very important feature. Why? Because this gives us special spherical triangle, which is called as right-angled spherical triangle. And such triangles can be much more conveniently solved using Napier's rule.
Okay, so let's stop it here, beta. We are almost done for our session. The session is almost complete, so let's take a break. What time you should be back?
45.
12:45.
12:45.
Okay, beta. All right. See you at 45.
Okay, sir.
Thank you, sir.
Thank you, beta.